Alright, this is a review for use substitution. I mean, we're supposed to do Calc 2, but I'm starting off with use substitution because many of the students had problems in it. So, first of all, let's introduce ourselves. Why do we do substitution? Now, the reason we do substitution is that it is one of the methods that have been given to me to get out of that integral. So if we see this over here, let's start with an example. Over here. Now, we can technically do that without substitution, but opening this up would be a nightmare. So what we do is that we take the complicated part as a variable, and then our second job is to change the dx over here. Now the integral, right? It has two parts, the integrand and the dx. These two can be imagined as like parentheses we have and there's something inside, right? This is the starting of the integral and this is the ending of the integral. Now, the dx, right? The variable right next to the d, that represents that what this integral is valid for. That this integral can be only be solved for this variable over here, at least for our knowledge in calculus 2. This variable over here and this whole integral is only valid for this variable over here. Now, as for what the actual method is, we have two goals. First, to take care of this complicated part, and the second goal is to change this dx, this x over here, this variable, into another variable for which that integral will be valid for. Let me get my chat up my screen. So okay, if I don't see your chat, just speak up and tell me that you have some issues. Okay. All right. Now, this example is pretty simple. We are starting off with this, and over here, it's basically my intuitive thinking that what seems the most complicated to me over here, like what makes the most sense to take as my other variable. Now, I know that particularly Dr. Grinchpon, he doesn't like using the word u substitution because we use the u in partial fractions too, so it causes uh, like confusion. So what I'll do is that I'll take the complicated part as the variable t or any other variable other than u. So let's take t equals x squared plus 2 because this is in the thing that we are dealing with, right? Now what we'll do is that we'll take a derivative of this. What does that achieve? This introduces dt and the dx in my equation. The first part to replace the complicated part, and the second part to replace this dx with something over with dt. Once I have found a thing to replace with the t, the rest of this stuff is something that I have to arrange in some sort of a way to get rid of the x over here and the dx over here. So let's work on it. Over here, derivating this, the x squared became a 2x, bringing the power down and reducing the power by 1, and the constant became a 0. This can be written as, well, normally when we have like y equals like x squared, right? We usually say that dy over dx is 2x. Now we can bring this dx on the other side, like multiplying by dx on both sides, and this dx can be brought over here. And that's how I got this over here. So I'm just going to bring the dx on the other side. Now let's look at our question. Let's rearrange it a bit. These are two functions over here. Let me rearrange them. Let's put this over here, and let's put this over here. Okay? Now I can clearly see that this is equal to this, so I'll be putting t over here. But I have a 3x dx over here, but I have a 2x dx over here. So let's rearrange this so that it looks like this. What I'm going to do is that I'm going to divide by 2 on both sides over here. So dt over 2 equals x dx. Now I have achieved x dx. What I'm missing is 3. So I'm going to multiply by 3 on both sides. So 3 over here. Now I've got exactly this over here and exactly this over here. All that remains is to replace stuff. Over here, I can make this. So the x squared plus 2 becomes t to the power 7, and 3x dx becomes 3 over 2 dt. 3 over 2 dt. So we have achieved that we have made the complicated part into simpler, and we have replaced the remaining of the x variables with something with the variable that we changed it with, t. My next step would be, well, always whenever you see a constant, just take it outside. It's much easier. You can always take constants outside. Now I'm gonna make an assumption that you guys would know about the basic rules of integration, basically bringing the power down. I mean, increasing the power 1 by 1 and dividing by that power. We can bring the constants outside, and the antiderivative of 1 over x is log of absolute value of x. So does everyone know about this? Quickly, if I could get some yes in the chat. Do we all know about the basic things? Okay, all right, perfect. So now over here, what's the antiderivative of t to the power 7? Can I get some answers in the chat, or somebody wants to speak up? T to the power 8 over 8. Perfect. So this becomes 3 over 2 times t to the power 8 over 8. But let's remember that I had to replace this. My original question was in the x variable, so I have to replace the t with the value that we assumed it to be. So this becomes 3 over 2 times x to the power, sorry, this was x squared. Was it x squared? Yeah, it was x squared. Alright. So x squared plus 2 to the power 8 over 8. Now you can also add a plus c in the end. Now you can multiply on the bottom and simplify it. Becomes 3 over 16 x squared plus 2 to the power 8 plus c. Now do not attempt to open this up. Do not waste your time. It's not worth it. And this would be a perfectly acceptable answer. Do we have any doubts till now? Anyone? All right. So the 2 over here, right? And the 8 over here. 2 times 8 is 16. You see? The 2 was in the denominator. The 8 was also in the denominator. They multiplied together to make 16. All right. Now let's move to the next one. So let's pick. Now B is something that you can do without substitution, but it becomes much more easier with substitution. But that's something that's really easy. So let's move on to something more difficult. Let's do something like, Let's do f. So f says that this is 3x cubed plus 1 cubed dx. Now, from here, the most complicated part that seems to me is in the denominator over here, 3x cubed plus 1. And I also see that if I derivate this, I would get a squared power. And I have a squared power up top. So, let's do that. This becomes... So let's do that. Let's take t equals 3x cubed plus 1 to the power of 3. Wait, not the power of 3, just that. Yeah. If we derivate that, we get dt equals 9, which is 3 times 3, 9, x squared dx. Replacing, and what do we want? We took care of this, now we have to take care of that. We have 9x squared dx. We have the 9 as extra. So let's move the 9 on the other side. I'm going to divide by 9 on both sides. So, dividing by 9 on both sides, I got over here. And now I have exactly what I want. I have this. I have changed the remaining of the x stuff into the dt variable, the t variable that I took it as, and the bottom stuff I took it as t. Substituting everything. Now that is why it's called substitution, because the x squared over here, we uh, we are the x squared dx, we are substituting it with this, and this we are substituting it with this. That's why it's called substitution, because we're literally substituting everything to move through our interderivative. So the x squared dx gets changed into dt over 9. This over here gets changed into this, and this over here gets, this inside thing gets changed to t. So I would just have 1 over t cubed. Now what was my next step that I always tell? Move the constants outside. Makes stuff a lot easier. 1 over 9, and I have 1 over t cubed times dt. Do we remember how we can deal with antiderivating with the variables on the bottom? Well, all we have to do is to move them to the top. Yeah, negative exponents, perfect. So all we have to do is I have to move them on the top. Okay, in any case, if you cannot see my screen, or if I forgot to share my screen, or like basically I'm talking about something and you guys cannot figure it out, just tell me that you have not shared your screen, okay? Because I do that quite often. Alright, now there is a property of algebra that if I have a variable on the denominator, I can move it to the numerator, but the sign of the power would flip. So over here I'm using the same thing, 1 over 9, and this becomes t to the power minus 3 dt. Basic antiderivative. Increase the power by 1 and divide by that power. So t to the power minus 3 plus 1 over minus 3 plus 1, and the derivative is done. Okay, I mean antiderivative is done. So 1 over 9, and this becomes t to the power negative 2 over negative 2. I can now again move it back down, and the power would flip again, the sign of the power, 1 over negative 2 t squared. Now we have reached here. My last step would be substituting back the value of t, which was 3x cubed plus 1, which becomes 1 over 9, 1 over negative 2, 3x cubed plus 1 squared. See, quite easy. All you have to do is to guess the thing that you have to take the t as, the substitution as, do the substitution, make an arrangement to get rid of the other stuff, and then replace it over here, substitute things. Then you'll get a much simpler thing. Excuse me. You'll get a much simpler thing to work with, and then just substitute stuff back in. Is this one clear? Anyone with any questions?
Yeah.
Where does the dt go? Okay, now after you take the antiderivative, right? The integrate, and this goes away. This is after we have taken the antiderivative. Over here, this means the antiderivative has yet to happen. And this is after we have done the antiderivative. No worries. If you have any question, just speak up. This is the best time to like basically improve yourself. Let me go ahead and add your voice into the recording so the recording can also hear you. And I think I minimize this. Yep. All right. Now, let's do. Now, this is something you can also do with your other methods, but we'll cover this later on. You can also do this with substitution, in which you take, I think that 2x as the t, and then sine t tan t would become something. Okay, how about we do this? And give me just 1 second. Just give me 1 second. Make a new window. The PDF I'm trying to open it doesn't want to open. It's giving me a bit. There's some bit of issues. Let's see if it's over here. Let me try to download this thing. I see. Nothing wants to download. I'll go over here and just give me 1 second, guys. Alright, that works. Okay. The thing is that I saved everything on my laptop last night and I forgot my laptop at home. So I'm trying to gather everything up on the spot. Perfect. Okay, that works. Now let's see if this will open. No. Let's open this up in here. Okay. Perfect. Now I can see it. Okay, we are doing the question 13th G. Okay, let's continue. So 13G is secant of 2x and tangent of 2x dx. Over here, the thing I want to take my substitution as is the variables inside. Now I know that from my chart over here. If I could go over here and show you the chart, that secant x and tan x is the antiderivative of that is secant x. Now make sure that the angle is only x. It's not 2x. It's not d2x. It's just dx. So that's why we will have to use substitution in this case. So let's take the t as 2x. If we derivate that, we get dt equals 2dx. Now the first step was done, replacing it with the angles over here. And the dx is what we have to deal with now. Let's divide by 2 on both sides. So this becomes dt over 2 equals dx. Now I have this that I can replace it over here, and I have 2x that I can replace by t over here. So I get secant of t tan of t dt over 2. Now my first recommendation after substituting everything was to move the constants outside. Now from the formula, or basically our helpful integrals, we know that secant x and secant x tan x is secant x. So I can just write this as half of secant t plus c, and I took my d as 2x. Now secant of 2x over 2 plus c, that is my integral. Okay, it wasn't that hard. It's just choosing the things to take the substitution of. Alright, now let's move to substitution with limits when I have bounds. Over here, let's do 14th. Okay, first of all, from 13, does anyone have some specific thing that they want me to do before I move over to 14? Because we have ample of time today to cover substitution.
Can you show the answer again?
The answer? There you go. And this was G. We replace the angles inside, or the theta inside, with t, the 2x with t, because the original integral, It's for secant x and tan x, not secant 2x and tan 2x.
Got it. Thank you.
Does anyone have any specific ones that they would like to do in 13? When we have a trigonometric integral, what is... Oh, no, nothing. We were just doing 13th and we covered this secant x tan x example. I was gathering up a few stuff I have. And yeah, basically we did this. And I was just asking if somebody has some clearing issue in 13th, if that they want me to do. Okay, Aryan says when we have a trigonometric integral, which is a normal antiderivative, we substitute what's inside of the parentheses. So whenever we have a trigonometric integral, now this is for the knowledge before Calc 2. If it is in the form this of this over here, in which we have a single x over here, which we do not have any like 2x, 3x or anything like that, then we will directly use these formulas over here. But let's say if we have some other angle inside of it, then we will substitute it back with what's inside of the parentheses. And that would generally work. Okay?
Could you please do 13E?
13th E. I can. Alright, let's do 13th E. 13th of E. Alright, now. First of all, Aryan, does that answer your question? Okay, good. So now we have 2x square root of 4x squared plus 4 dx. Give me just 1 second. Okay. Now, what's the most apparent thing? What's the most apparent thing to take the substitution of? You can speak it out, right? So let's take that as t. 4x squared plus 4. The derivative of this would be dt equals, what would be the derivative?
4x. Oh, wait, no, 8x. 8x. My bad.
Yes, 8x dx. Never forget the dx. Okay? Now, let's rearrange our question. Let's keep it like this. Oh, not this. And this over here. And keep this over here. Right? Just two things that were multiplying with each other. Now, did we find this? Yes, we did for this. But we have 2x dx over here. We have 8x dx over here. Now, if you just want to like not apply with some brain, just move the constant over here, any constant that there is over here, and just multiply the constant that's over here. That would perfectly work. But even then, you can just divide by 4 on both sides. So this would make this 2, and I would get dt over 4 equals 2x dx. And now I have specifically this that I need to replace this with, and I have this that I can replace this with. So I would get integral of t root t, and 2x dx became dt over 4. What was my next step after substitution, or my next suggestion?
Move 1/4 out.
To move the constants outside makes life a lot more easier. Alright, what am I left with? Root t dt. Can I write this as 1 over 4 t to the power 1 over 2 dt? Just some power. Right?
Yeah.
And can now just normally we would antiderivate this, increase the power by 1 and divide by that power. 1 over 4. And the integral goes away because we have solved the antiderivative. Q to the power 1 over 2 plus 1 over 1 over 2 plus 1. That's 3 over 2. 1 over 4. T to the power 3 over 2 over 3 over 2. Now this over here doesn't have, this 2 over here doesn't have anywhere to go. So it's going to go on the top. It's gonna go over here times 2. Okay? And it's gonna look something like this. Now, if it doesn't confuse you, this 4 and this 2 are just multiply are just like this is basically 2 over 4. Does that confuse you a bit?
Yeah.
This 2 over here is multiplying to t 3 over 2 and everything is just multiplying over here. Can I
Yes.
can I just do this? Does that work?
Yeah.
All right, perfect. So I have t3 over 2 and this becomes 2 times 3 which is 6, right?
I guess. Okay,
And
reduce. I see. I see. I see. Like you just reduce. Just reduce.
does anyone have any question? I can hear someone speaking. All right.
I got it. Because you just reduce the fraction. Because if I this, if I do.
I'm sorry, I can't hear you well.
Oh my mistake.
Oh,
I was talking to myself. I didn't realize
oh,
my mic was
you were
my.
talking to yourself.
I was actually going to ask a question about how you got 1/4. I figured it out though. Thank you.
Okay, okay, no worries, no worries. Yeah, just tell me if anything is an issue. Because the thing is that I don't have a chat with a pop-up. This platform, I don't like it. It restricts me. And today, like, well, I'm going on a bit of a rant. I am so the thing I'm logged through in right now. It's a student account, and it's not letting me log into a host account. I don't know why. I'll get it fixed though. All right, now this t over here, I took it originally as 4x squared plus 4. So I'm going to write it like that. Becomes 4x squared plus 4, 3 over 2 for 6 plus c. 4x, yes, 4x squared plus 4. Perfect. Now, did you understand that?
Yeah. Thank you. And is he going to ask us like just substitution questions on the exam or no?
No. But I'm doing this because this is the backbone of Calc 2, and you guys would need this.
Okay, got it. Thank you.
All right. If we are done with this, should we move on to 14? Do you guys have any other questions from 13? Should I move ahead? All right, then I'll take that as a yes. All right, let's move to 14. Let me make sure the recording is still going on. Thank God it is going on. Okay, defying all the technical difficulties today. Let's see. Our question is root 8y plus 1 dy. Now, the y over here, it is just some variable. It doesn't matter if it's y, z, t, a, b. A variable is a variable. So we will just solve it the normal way. Now, well, there's two things. Dr. Grinchpon in particular, he doesn't like to first change it to definite and then first change it to indefinite and then back change it back to indefinite to definite. So, and but like the I don't know about Dr. Rosier, but Dr. Miller doesn't care. So I am going to teach it both of the ways. First, I'm gonna teach you the way Dr. Grinchpon wants it, which I think, I mean, they both are kind of easy. They're not that difficult. All right. Now, if anyone can tell me what do I take my t as, my variable as for substitution, if anyone could just tell me.
8y plus 1.
Perfect, 8y plus 1. Let's take t equals 8y plus 1. And if I derivate that, I get dt equals 8 dy, right? So I have this to substitute over here. I need just a dy, but I have 8 dy. Let's move this 8 to the other side. Becomes dt over 8 equals dy. Well, perfect, 8y plus 1. Perfect. I was distracted for a second. How does Dr. Grinchpond prefer it? That's the way I'm going to do it right now. All right. Now, when you are here, let's first set it up. So, 8y plus 1 gets replaced by t, becomes under root t, and the dy becomes dt over 8. Now, the bounds, they will not stay the same. Why? These bounds were valid for the y variable, and because we change the y variable stuff itself, we will also have to change the bounds. How to change the bounds? It's very simple. Yeah, those bounds were taken for they taken for y, but now we have to take it for t. How to change those? Pretty simple. I say that 8y plus 1 is equal to t, and these are for t. So all I need to do is to plug in these over here. So the 4, if I take it as, let's say t of upper equals 8 of upper, which was 4, plus 1. 8 times 4 is 32, becomes 33, t of upper. And t of lower equals, now this was 0, so I just need to plug in 0 over there. So becomes 8 times 0 plus 1, which is just 1. T of lower is 1. So the upper is 33 and the lower is 1. Now the next step would be to forget all of this ever existed. Was never there. Okay? Might seem a bit strange, but you'll get my point. If we forget it was ever there, we can treat this as another question. My bounds are set for some other thing, and all I need to do is focus on this. Now this makes everything a bit simpler. I don't need to back sub stuff. I don't need to make sure that stuff is like the bounds are not set up or anything. Once I make sure that this is successfully transformed into this with the correct substitutions and the correct bounds, I can forget all of the above things. Now, let me just make sure I did everything correctly. Okay, I did. Now, this is a to t to the power 1, t to the power 1 over 2. We just did something like this. Also, meanwhile we are doing that, let's move the constant outside. 1 over 8. Looks nice and easy. Increase the power by 1, divide by that power. And while taking the bounds, I always keep them in like this. So t to the power 3 over 2 and 3 times 2. It was originally 3 over 2 over here, and the 2 came over here. And my bounds were 33 and 1. Okay? All I need to do is plug in my bounds. My bounds are always upper minus lower. So this becomes 1 over 8, 33 to the power 3 over 2 over 3 times 2 minus, don't freak out by looking at this. This is nothing. 1 to the power 3 over 2 over 3 times 2. Now 1 to the power anything is 1. Even 1 to the power 0 is 1. And 1 times 2 is 2. Becomes 2 over 3. Now, you can open this up. Would be sort of a mess, but we can do it. Okay. 1 over 8. This is 33 to the power 3 over 2 times 2 over 3 minus 2 over 3. The denominators are the same. So let's combine them. Becomes minus 2 over here, like this. And when we open this whole thing up, the 8 gets multiplied over here. So I get 33 to the power 3 over 2 times 2 minus 2 over 24. That's your final answer. Now it looks a bit complicated, but trust me, if you just go step by step, it's all good. I plugged in 33 over here, 1 over here, upper minus lower. Then I combine the denominators because they are the same. This becomes this thing minus this thing. And then I opened up the big brackets. Alright. Would he take it in this answer, or would he want you to calculate 30? No, he would take this. That would be insane. I Yeah, he would take this, don't worry. That's a perfectly reasonable answer. Okay? Now, even if you do it like this with other professors, they will be more than happy. But do you still want to know about the other method? It's exactly the same, you just put stuff back in. In my opinion, I get where Dr. Grinchpon comes with. This is much more simpler and just to come over here and forget everything else. But does anyone have any doubts? Anyone?
Yeah,
Mm-hmm.
if you don't mind, could you just like walk us through when you plugged in T again, like from there, like
Yeah,
after
I
you
can. It's
integrated?
no worries. Don't worry. That's my job right now. Okay, now I had t right over here. T
Yeah.
was equal to this, so I put t instead of that over here, right? I also
Yes.
needed to replace dy. After derivating this, I got t equals 8 dy. I divided by 8 on both sides and I got this. So now I can replace dy with this. I can replace this thing with t. And that's what I did over here. Now because this has bounds, I also need to change the bounds. How do I change the bounds? I use this. As I've already declared that t is equal to this, all I need to do is plug in those bounds over here. If I do 8 times 4, I get 32. And 32 plus 1 is 33. So my upper bound becomes 33. And my lower bound is 0 originally. If I plug that over here, it becomes 8 times 0 plus 1, which is just 1. So my bounds change and everything else changes. Now this can be taken as another example, like another question entirely. We can forget about if it was ever like this, because this would lead me to the right answer. Okay, does that answer your question?
Yes.
All right. So let's move on to the other one. Hum. Uh, in 14th, which question do you guys want to do? Let's take it from you guys. E. All right. E. First come, first serve. E looks a bit scary, but trust me, it's not. First of all, can anybody tell me what's the derivative of tan x?
Secant square.
Perfect. And that is the way to know what to take my t as, what to substitute in as. Okay? So, with that information, what do you guys think I should take the t as? not, yeah. You're right. 3 minus tx, tan x, I mean. Perfect. Let's start from that. Okay, good. You can see my screen. Let me quickly change it to my tablet so you can see my screen better. All right, now. So, you said that let's take the t equals 3 minus tan x. All right, now. Uh, so the next step is to derivate it. Let's derivate it. dt equals constant changes to 0, and the tan x changes to secant square x. Becomes negative secant square x dx. Now, I got t, I got the complex thing I wanted to replace. I have secant square x dx. But over here I have negative secant square x dx. How do I change that? Let's multiply by negative 1. So multiply by negative 1, this becomes negative dt equals secant square x dx. I can change this now, and I can change this now. This over here becomes negative dt, right? Changing this part over here with this becomes negative dt. And on the bottom, I have taken this thing as t. So it becomes t. Essentially, this thing just becomes, if I can write this as, negative 1 over t dt. Do we agree with that?
Yes.
Perfect. All right. Now, before dealing with the constants and everything, let's take a look at the bounds. Now, because this thing has bounds, I have additional steps. I said that t is equal to 3 minus tan x. Now, guys, you are in Calc 2. You should know the unit circle table by now. It's been 2 classes, pre-calculus and calculus 1. So please know the unit circle values by now. If you have some difficulties regarding that, you can come to me and I can teach you a easy way. Or if we have some time left by the end of the class, I can tell you that easy way. Alright, now. So I said that t equals, so let's say t upper, we are first calculating it for t upper. 3 minus tan, and what was my upper value? It was pi over 3. So pi over 3. Can anyone tell me what's tan pi over 3? Tan 60 degrees. Anyone? Tan 60 degrees, tan pi over 3. Okay, I'm gonna count to 3. 3, 2.
It's
Huh?
square root of 3, right?
Perfect. Thank you so much. Okay, it becomes square root of 3. So 3 minus square root of 3. That's my t of upper. Okay, let's do t of lower. Was 3 minus... Okay, what's tan of 0? That's an easy one. Come on, guys. Tan of 0. 0. Thank you so much. Alright, so this becomes 3. T of lower is 0. T of upper is 3 minus root 3. And the lower is 3. And what was my next step? My next step was to forget everything. And just come over here. Okay? I'll keep it over there for now. For you guys to simmer it down. I'll wait for some time. I put the thing over here, upper, put the thing over here, lower. Got the lower, got the upper, substituted the stuff I wanted, and I moved it over here. Alright, let's begin now. So what was my first step after substituting stuff? Anyone? Moving the negative out, moving the constant out precisely. So this becomes -1. Okay, now what's the entire derivative of log of absolute value of t? So this becomes -1 outside log of absolute value of t, and in the inside I have 3 minus root 3 in the upper and 3 in the lower. All I have to do is to plug in the upper and lower bounds now. This becomes -1 log of 3 minus root 3 minus log of 3. Now, if anybody could tell me, is 3 minus root 3 a positive value or a negative value? Positive value, right? It's like 3 minus 1.7 something, so it's a positive value. So I can write the absolute value as it is. And the 3 is also positive value, so let's just write it like that. This is particularly something Dr. Grinspon pointed out in the class when I was studying with him. So I would change that. I would change the absolute value and basically compute what they would be. Okay, now let's put the multiply everything with the -1. If I plug the -1 over here, this will become negative and this will become positive, essentially reversing them around. So this becomes log of 3 minus log of 3 minus root 3. Okay, did everybody understand that? Any questions? Let me bring everything a bit down here. All right. Any question, guys? Did everybody understand that? Recap. Took this as t because I knew that tan x is secant square x. dt became negative secant square x dx because of the negative over here. Took the negative over there, replaced it over here, replaced this over here, computed the upper and lower bounds from here, and got this. And then it's just a simple question. Okay. Any questions?
Yeah, wait, so what you just explained, how'd you make the log of 3 minus root 3 negative and then log of 3 positive?
Do you
You
see the
just said
negative
some.
over here?
Oh, okay.
This
Yeah.
came over here, this came over there. And then this became negative, this became positive.
Oh, all right.
Okay,
Got it.
thank you for
Thanks.
asking the question. Some students also might have the same doubt. It's good. All right, let's move on. Now, some other question from 14 before I move to 15, because 16 is something you guys don't really see.
We can't see the questions.
Oh, thank you so much. See, that's something I told you about. All right. Anything from 14?
Yeah, could you do either C or D?
Which one, C or D?
Um, actually, can you do D?
I can.
Okay.
Just give me 1 second and let me look at if these are something we could do. Actually, we can. But I would much rather focus on the stuff above because you would use that more right now. Okay, let's do D. So 14th d. Let me copy it down, and then I switch back the whole thing back again. So 14d is 0 to 1 over 2. Is it 1 over 2? 1 second, where's the projector? 1 over 2, yes. And x over root of 1 minus x squared dx. Now, thinking intuitively, what do you think I should take my t as? Over here, what do you think I should take my t as? Any guesses?
1 minus x squared.
Perfect. First, it looks a bit complicated, and the x square would derivate to a single power, right? The power would get knocked down. Let's take t equals 1 minus x squared, and let's derivate that. That becomes dt equals minus 2x, right? Now we have dealt with this, but we have an x dx on top. Also, do not forget to put an dx over here. We have an x dx up here, we have negative 2 x dx over there. So let's divide by negative 2 on both sides. This becomes negative 2 over here, and now I have exactly what I need to replace it with. So let's replace it. So this becomes, the x dx gets replaced by dt over negative 2, and the root x, the root under gets changed to root of t. Now let's move the constant outside. Oh, maybe we'll do that later. Let's first deal with the upper and lower bounds. So t of upper equals, I have to just plug in 1 over 2 over here. This becomes 1 minus 1 over 2 squared, which is 1 minus 1 over 4 squared. 1 over 4. That becomes 4 minus 1 over 4. That is 3 over 4. So t of upper is 3 over 4. Let's see what's t of lower. T of lower is 1 minus 0 squared, which is just 1. So I have the upper and lower now. Upper is 3 over 4, lower is 1. Okay, I can rewrite this as 1 over negative 2 times 1 over root t dt, and 3 over 4 as my upper bound and 1 as my lower bound. My next step after substitution was to move the constant outside.
Yeah. I was asking.
So this goes over here, and this out, this over here. All right. And how to solve this? Let's write the root t. Let me see if I've shared this correct screen. Okay, fortunately I have. Now this becomes,
Isn't that also subject to
let's write this as 1 over 2. Lower bound is 1, upper bound is 3 over 4. And let's write this 1 over t to the power 1 over 2. The square root is just 1 over 2. And now let's bring it to the top. What happens if I bring it to the top? The power remains it remains the same value, but changes its sign by a negative. Now my rule to antiderivate something was increase the power by 1 and divide by that power. Increasing the negative half by 1 would just give me half.
I don't think
So this would give me
it's too bad.
t to the power 1 over 2 over 1 over 2. This 2 goes to the top over here.
But I don't think
Goes over here. 2 times t to the power 1 over 2, and the upper bound was 3 over 4. Lower bound is 1. This becomes minus 1 over 2. 2 times 3 over 4, 1 over 2, minus 2 times 1, sorry, 3, yeah, 1 to the power 1 over 2. Alright, square root of 1 is just 1. So this becomes 1 over 2. And I can do this as 2 times root 3, the square root of, so basically, if I open this up, the square root goes over here and over here. Square root of 4 is 2, so I can write that as 2 minus 2. This becomes negative 1 over 2. The 2 and 2 cancels out, becomes root 3 minus 2. And now if I open this up over here, this gets distributed over here and over here. This becomes negative root 3 over 2 minus or plus 2 over 2 comes 1 over here, and all I get in the end was 1 minus root 3 over 2. Went by a bit fast. Let's rewind it back a bit. So when I got over here, I just increased the power by 1 and divide by that power, and all I did over here was open up the bounds. Put this over here, put this over here, and then just basic algebra. 1 over 2, I mean 2 and times 1 to the power 1 over 2, that's just 1. 2 times 3 over 4 to the power 1 over 2. I can just cancel these out because the square root goes over here too and changes 4 to 2. Square root on 3 just stays over there. And basically then I multiply this over here, and they switch places, cancel the 2 over here, and that's how I got to the. Yep.
When you got t raised to 1 over 2 divided by 1 over 2, how'd you get 2 times t raised to 1 over 2 after that?
Are you asking from here to here?
Yes, because wouldn't it be t raised to 1 over 2 divided by 1 over 2?
Alright, yeah, it is 1 over 2, right? This 2 has nowhere to go, so it goes to the top.
Oh, okay.
Alright.
Okay. Got it. Thank you.
Okay. Anything else from, so is this one clear?
Yes.
Alright, does anyone have any questions? If you do, don't be hesitant to ask your questions. Alright then. Let's move to the next one. Let me do 15th now. So 15th takes advantage of the arc sine, arc tan, basically the arc trigonometric functions. So over here, this one in particular, a plus x squared, so 2 plus x squared dx. Actually, let me take a look at them again because it's been quite a while since I looked at them. All right, these ones over here. Okay, students studying with Dr. Miller. Let me change the screen. See, I wasn't sharing it. These over here, right? Students studying with Dr. Miller. This is his favorite question. I mean, it's his favorite formula or integral. Remember this, please. This is very important. Very, very, very important. You might put this on the test. Alright, with that warning ahead, let's take this. Let's see if I can put them on the side as a little photograph on my thing. Let's save this. Oh, it automatically saved the screenshot. Perfect. Okay. What if I can add an image? Image formula. Image file. And picture, screenshots. Perfect. Nice. I love OBS for recording. Let's have this thing up here. And let's look at our questions. Now let's quickly go through our questions over here. Let's do 15. Over here, now, if you look at the formulas over there, which one does it look more likely? Okay, wait, can you guys see it? Oh, I changed the thing. Let me get the formulas again. Here, over here, yeah. And let's get the formulas over here. Okay, now this one over here, the most likely that it seems to be is the 1 over a square minus x square formula. How do I do that? Over here, I have 2. This is not in the form of a square. So what I do need to do is that I need to change it into the form a square. So this becomes 1 over, the 2 becomes root 2 squared. Can I write it like this? Well, this is not really substitution. It's basically you need to know this. Do we get how we did this? I can write 2 as square root and squared root 2 squared, right? 1 over square. Yeah, that's the right answer. Good. All right then. Now looking at my template, this is a and this is x. So this becomes 1 over a, which is 1 over square root 2, arc tan x over square root 2 plus c. Okay, let's do b quickly. b is 1 over 3 plus 4x squared dx. I can write this as 1 over 3 square root of 3 squared plus 2x whole squared dx. Oh yeah, now I need to use substitution because the formula is for x squared, not 2x squared. All right, now let's take t equals 2x because I need an x over here. What I'll get is that dt equals 2 dx. And I can change that to dt over 2 equals dx. I have this over here. I can change this over here to t. So let's write that like that. So this would be 1 over square root of 3 squared plus t, and the dx becomes dt over 2. I can take the constant outside, and now it has been set up in the format I want, the 17th formula on the screenshot. So this becomes 1 over 2, there was 1 over 2 already outside, 1 over a, so a is root 3, arc tan x is t, like the variable is t, over root 3 plus c. Not right now. Outside plus c. Now our question was in the form of x, so we need to substitute back the value of t, which is over here. So this becomes 1 over 2 arc tan 2x over root 3. Now remember I told you about this is not a substitution question? It is. Forget that. Plus c. You can open this up, becomes 1 over 2 root 3 arc tan 2x over root 3. Okay? Any questions regarding this? The reason I took this over here was because in the question I have a square plus x square, and the x needs to be, the variable just needs to be there without any constant. So I took it as t. Let me switch back. So you only use substitution with arcs when there is a constant in front of x. We need to use substitution when it doesn't seem to be set up in the way it seems in the formula. So over here, when I put everything together, I saw that, oh no, it doesn't look like it has been set up. Whereas let's look in C. In C, there is no constant in front of x. But you can you can think of it that there's a constant in front of x and then we need to use substitution. You can think of it like that. But a better way would be if it doesn't look the way it is in the formulas. Over in C, I can see that it becomes 1 over 12 squared plus x squared. So my a would be 12 and my x would be just x. And after doing all of that, I can just plug in the 8 and 0. Now, because I have only 2 minutes left for this session, I would be taking doubts in the end. But does that answer your question? Good. Does anyone have any questions in the end? Tomorrow is when I would have the bigger session. I would be doing the entirety of test 1. So join that. It would be a nice session. This one was like a warm-up to get ready for that session because I want the students to know what use substitution is. Any questions? Alright then, I would be stopping the recording right there.